Hey guys, in this video the brilliant Mr. B is going to be taking you through lots of really tricky surds. A few examples worked through slowly here. These are sort of level questions that you're going to need for your further maths or level 2 maths or as an introduction to A-level maths. If you want more examples for you to practice, then there are loads just waiting for you over on my website.
We're going to recap the Surds topic, and with the first question, we have the root of 77 divided by the root of 11. So how do we do this? Well, to show you, I'm going to show you a generalized formula that represents it. So let's say we are having the square root of a number. Let's call it the square root of a. And we are dividing it by the square root of another number. Let's call it b. Now, a little trick you can do here is that you can rewrite it. And the way that you rewrite it is you can draw a large root symbol. And on the inside of that, we're going to do a divided by b. Square rooting the numbers individually and then dividing is exactly the same as dividing them and then square rooting that answer. And if you're not sure about that, get a calculator, pick some numbers for a and b, perhaps the 77 and the 11 that are in the question, and calculate it both ways and see if you get the same value. You should be getting the same value. So looking at our question, root 77 divided by root 11, we are going to rewrite it using this method. So we're going to write a large root symbol, and on the inside of it, we're going to do 77 divided by 11. And we can do 77 divided by 11, it's 7. So our answer is going to be the square root of 7. Now, the square root of 7 isn't a square number, so we can't calculate it using what we know. It's going to be a decimal number. And if you got a calculator and you calculated the square root of 7, what you would get is 2.645751311. And now that's been cut off my calculator screen, but that number would actually continue. And so a device capable of doing more decimal places would have not more numbers after that. And it's a rational number, so this would just go on forever. Which is the better answer? Is the value the better answer? 2 and a bit. Maybe it makes more sense to you. But root 7, well, it's a little bit more abstract. You don't immediately know that root 7 is going to be 2.6 and a bit. What it does for us is that it doesn't round the number. It's an accurate answer. And you'll also notice it's a lot shorter. So what we want to do is we want to leave the root 7 as the answer. So I'm just going to write the decimal version. Now, you will occasionally need the decimal version. And what you're looking out for is if you're simplifying or you're finding the value. If you're simplifying, you want root 7 as the answer. If it asks for an exact answer, you want root 7 as the answer. But if it asks for the value, then you're going to want the 2.6 and a bit. So now we're moving on to an addition question. And again, we can generalize this. So we have 3 root 3 plus 10 root 3. So let's say we have a number a, and it's been multiplied by a square root. Let's call it square root of x. Then we're adding on to it another number b that's been multiplied by the square root of x. So if we look at our question, you can see we've got the 3 and the 10 in front of the root symbol. That's our a and b. But you can see that both roots are the same. They're both root 3. So by writing them both as root x in the generalized version, I'm just saying they've both got to be exactly the same number. This follows the same rules as adding algebra. So if you had ax plus bx, then you would have a plus b multiplied by the x. Instead of an x, we've got a root x. So I'm just going to write in root x. Now, the generalized version can look a little bit abstract, so we need to go through the question to kind of see how that would work. So what we're going to do is the numbers in front of the roots, the 10 and the 3, we're going to add those together. That'll give us 13. And then we're going to keep the root the same. And if you think about it, if you've got 3 lots of root 3 and 10 lots of root 3, then altogether you're going to have 13 lots of root 3. And again, what you can do there is you can multiply 13 by root 3. That's going to give us 22.5. 0.51666605. And again, this number has been rounded. That number will continue. It's a rational. There'll be no pattern and there'll be no end to the number of decimal places. And what's going to happen is you're almost always in questions like this going to be asked to simplify it. And 13 root 3 is the kind of the shortest way to write it rather than simplest, because you might understand 12 and a half a little bit better, but it's just over 12 and a half. And that bit of accuracy is dealt with by having it written as a square root, like the root 3. So let's get rid of the decimal version. And while we finish the question, there's one more detail to mention, which is this works the same way with a takeaway. So we've had a number multiplied by square root, not added, this time it's going to be taken away from a different number, but multiplied by the same square root. Then what's going to happen is you're going to take away the A and the B, get an answer, and then whatever that answer is will also be multiplied by that square root. So you can see it's exactly the same formula. We've just swapped out the pluses for takeaways. So we've looked at adding, subtracting, and dividing surds. Now let's look at multiplying surds. So we have root 5 multiplied by root 18. Now this works the same way as the division. So if you have the square root of a number, let's call it A, and we multiply it by the square root of another number, let's call it B, then what we can do is we can say that if they're being square rooted separately, it's the same answer if you multiply them and then find the square root of the answer. So the square root of A times the square root of B is the same as the square root of the answer to A times B. So going back to our question, we have the square root of 5 multiplied by the square root of 18. So that'll be the same as the square root of 5 times 18. And 5 times 18 is 90. So our answer is the square root of 90. Now, when we think about our answers, for example, the last question, we had root 3. In the first question, we had root 7. They're kind of small prime numbers as our answers. And we know for sure there's nothing to do with square numbers in those answers. Because, of course, if you take the square root of something like 16, we know that that's the whole number 4. But what about the 90? It's quite a large number. It's not a prime number. We can divide it by 9 and 10. So is there anything we can do here with this 90? Now, there is actually a way to simplify it, and it goes back to how we actually did the calculation in the first place. And what we can do is we can say that the square root of 90 is the same as the square root of 9 times 10. We have them kind of done together, so you multiply them and then root it. Using our formula, what we started off with, it's the same as square rooting them individually. So the square root of 90 is the same as the square root of 9 multiplied by the square root of 10. Now, why are we doing this? We're making it more complicated. Well, what's the square root of 9? We know it's a whole number. It's 3. 9's a square number. So we're going to change the square root of 9 to 3, and we're multiplying it by the root 10, which isn't a square number, and so we can't simplify the root 10. And so we've left it as 3 root 10. Now, which one is simpler, the root 90 or the 3 root 10? Well, it depends on what you need the surds for. On an exam paper, usually the 3 root 10 is going to be the answer that you're going for. Some of the reasons you might want to consider that people might have memorized the smaller roots. They wouldn't have memorized what root 90 is, but they might know roughly what a root 10 is. Or it might be that 3 can be used as part of another calculation, perhaps to cancel out a fraction or something like that. So what is the answer? Well, for this question, the 3 root 10 is going to be the final answer. So it might be you get 1 mark for the root 90 and you get 2 marks for the 3 root 10. So whenever you get an answer and it's using surds, especially if it's a large surd, always think, can I divide this number by a square number by a 9? And if you can divide it by a square number, in this case, we could divide the 90 by the 9, then rewrite it with that square number and change the square number into the whole number that rooting it corresponds to. Now, as well as simplifying surds, we can also have surds written out as a quadratic and have to multiply out the brackets like we have here. So we have in one bracket 7 plus the square root of 3. And in another bracket, we've got 9 plus the square root of 3. And we can't just do 7 times 9 and then 3 times 3. What we need to do is multiply it out like you would with quadratic and get 4 answers. So what I'm going to do, let's write this a little bit larger so we have a bit of working out space. So 7 plus the root of 3 and 9 plus the root of 3. And the best way to do this is just use arrows to make sure you've multiplied every number by every other number. So the 7 has to multiply by the 9 and the root 3. But you don't have to add it, multiply it by what's in the bracket with it. It's being added onto that. So we're not multiplying it by the root 3 in its own bracket. So 7 times 9 will give us 63. And 7 times root 3 will give us 7 lots of root 3. Now we've multiplied the 7 by both terms in the other bracket. We'll do the same thing with the root 3. So we have to multiply it by the 9 and multiply it by the root 3. So root 3 multiplied by 9, again, we can't do it, let's just leave it like that. 9 multiplied by root 3. And then root 3 multiplied by root 3. If you remember what we did with the easier questions, it's just the same as multiplying the numbers together. So it's going to be root 9. Root 3 times root 3 is root 9. So now we have our 4 answers. There's a few ways in which we can simplify this. So the first way in which we can simplify this is the middle two terms. We have a positive. Remember that symbols like that belong with the term after it. A positive 7 root 3 and a positive 9 root 3. So we'll follow the rules with adding surds. That is going to give us 7 plus 9, 16 lots of root 3. And then we're going to bring down the 63 and the root 9. Now, the next thing to simplify is the root 9, because we can do the square root of 9. And the square root of 9 is 3. So let's replace the root 9 with a 3. And now we actually have a 63. There's no symbol at the front, so it's positive. And we've got a positive 3. So we've got two sets of normal numbers. We can add those together. So in our final answer, the 63 plus 3, 66. I'm going to add it on to the 16 lots of root 3. And we can't go any further. That's our final answer. Now, you think about this with the way that the rules of algebra work. If you had 66 plus 16x, you couldn't add those together because of the x. And it works the same way with a root symbol. So we can't add a whole number 66 and then an expression that is 16 times root 3. They're kind of different things, so we're going to leave it as it is. The next question is going to work the same way, but now we have some negative numbers to be careful of. So I'm going to write this out in a larger format, just so I've got more space to working out. So we have 4 take away 4 multiplied by root 12. In our second bracket, we have 4 take away 3 times root 12. So we'll draw on the arrows. We'll multiply the 4 by both things in the second bracket. So 4 times 4 is 16. And 4 times negative 3 root 12. So the way to do this, do it the same way you would do it with algebra. Deal with the normal numbers first, and then deal with the roots. So we have 4 multiplied by negative 3, which will give us negative 12, and that'll be multiplied by the root 12. Same thing with the negative 4 root 12. We're going to multiply that by the 4. Now again, remember, positive and negative symbols belong with the term after it. So this is a negative 4 root 12. So deal with the whole numbers first. Negative 4 times 4 is negative 16. And then pop the root 12 on the end. And now for our final one, we're going to have negative 4 root 12 multiplied by negative 3 root 12. So again, whole numbers first. Negative 4 times negative 3 is going to give us a positive 12. And then we've got the root 12s. Now we've got two lots of them. So we could write it like this, root 12, root 12. Again, we go back to the easy questions. When you're multiplying a root 12 by a root 12, it's the same as the square root of 12 times 12. So what we can do here is rather than write root 12, we can write root 144 because 12 times 12 is 144. So in effect, what I've done here with a negative 4 root 12 multiplied by negative 3 root 12 is I've multiplied the whole numbers, negative 4 times negative 3, to get a positive 12. And then I've multiplied the roots together separately. So root 12 times root 12 is root 144. And now our next task is to go through this and look at things that we can simplify. So given it's a quadratic, normally the middle two terms will simplify. We have negative 12 root 12 and negative 16 root 12. So we can add those together. So negative 12 take away another 16 is going to give us negative 28 root 12. We had negative 12 lots of root 12, negative 16 lots of root 12, altogether negative 28 lots of root 12. We can bring down the 16 from the start. And then when we bring down the next bit, so we can bring down the 12, but what's the square root of 144? Well, the square root of 144 is 12. It's a square number. So 12, you could say it's been multiplied by the square root of 144, or we could say it's been multiplied by 12. So now, moving on to our final answer. We've added together the root terms and got that. Now we need to look at the whole numbers. Now, with the whole numbers, we do have this 12 times 12, and 12 times 12 is 144. So I'm just going to get rid of that and write in 144. By the way, this being the same number as in the root in the line above, that is a coincidence because the root 144 became a 12 and that was multiplied by a different 12. It is a coincidence. I mean, that 12 on the outside of the root could have been anything else. It could have been 10 and that would have given us 120. Now moving on to the final steps. So let's combine the whole numbers. We've got 16 and a positive 144. So if we add those together, that's going to give us 160. And we're taking away the 28 root 12. And that looks like a final answer. And this will give you most of the marks. But there's one more mark we can get here. And it's all about simplifying our answers. Now, in the previous question, it was a root 3. It was a small prime number. There was nothing to simplify with that. But this is a 12. Now, we can actually rewrite the root 12 as something. And when we rewrite things with roots, we're always thinking about square numbers. So is there a square number that can divide into 12? Now, there's not a lot. There's only 9, 4, and 1 that are underneath it. 1's not going to help us. It's going to make it stay the same. So can we divide it by the 9 or the 4? And we can divide it by 4. So we can say that root 12 is the same as root 4, root 3. Root 4 multiplied by root 3 is root 12. So now we have a root 4, and we know what root 4 is. Root 4 is 2. So in our final step of simplification, we're going to bring down the 160, and take away the negative symbol, but we're going to think about the whole numbers in this expression. Now we've got a 28, it's been multiplied by root 4, which is 2. So 28 times 2 is 56. And just so there's no confusion, let's just highlight where the 56 has come from. 28 times 2. And then on the end, we'll put the root 3. Which again, it's a small prime number. There's not going to be any more simplification from this point forwards. And again, why did we change 28 root 12 to 56 root 3? How is it particularly simpler? Again, it might just be a matter of people have memorized what root 3 is, so they can get a rough idea of what the value is going to be. Root 3 is the smallest surd, so that would be the one you memorize first. Or it might just be there'd be a reason, like maybe the 56 would cancel out with something in a more complex calculation. So that's our final answer. Now, on the previous two questions, we were multiplying roots by themselves. And if you multiply a root by itself, for example, root 7 times root 7, you get root 49. It's a square number because obviously you multiply 7 by itself in the first place, so root 49 gets you back to 7. Now, in this case, we're going to be multiplying roots by different roots. So let's have a look how this works. So let's draw it a little bit larger for some working out space. So 4 root 7, take away 7 root 2, and in the second bracket, 3 root 7 plus 3 root 2. So we'll be multiplying everything together. So the 4 root 7 will be multiplied by the 3 root 7. So in this case, multiply the whole numbers together first. So 4 times 3 is 12. And then multiply the roots together. Root 7 times root 7 is root 49, which we know is 7. So our first term will give us 12 times 7. Then we're going to multiply it by the second term in the second bracket. So again, whole numbers first. 4 times 3 will give us 12. And then root 7 times root 2 will give us root 14. And that's not a square number, so we can't simplify that one. Then we're going to move on to multiplying the second term. So remember, the negative symbol belongs to the second term. It'll be negative 7 root 2 multiplied by 3 root 7. So whole numbers first. Negative 7 times 3 will give us negative 21. And then root 2 times root 7, so do the root second, that will give us root 14. And then for the final one, negative 7 times 3 will give us negative 21. And then root 2 times root 2 will be root 4. And we know that 4 is a square number, so root 4 will give us 2. So it's being multiplied by 2. Now we need to look at simplifying this. So again, with a quadratic, the middle two terms are going to be adding together. We've got a positive 12 and a negative 21. So 12 take away 21 is going to give us a negative 9. And it'll be a negative 9 root 14. Just combine the two root 14 terms together, like you would with algebra. Then we've got the multiplications. So we've got 12 times 7, and 12 times 7 is going to give us 84. And then we've got the negative 21 times 2, and that's going to give us negative 42. So now we can look at ways of simplifying this. So we've got the two lots of whole numbers, and we can do that takeaway. 84 take away 42 will give us 42. And then we've got the negative 9 root 14. Now, the last thing to do here is think, right, okay, we've got root 14. It's on the larger side, it's not a prime number. Can we simplify? Well, what are the square numbers which are less than 14? We've got 9. We can't divide it by 9. And we've got 4. And actually, we can't divide it by 4 either. So we're not going to be able to simplify this surd any further. And so we already have the final answer. So we've simplified simple surd terms. We've simplified surds with brackets. So now what we have something that looks like it's already simplified. We have 4 over root 11. And we can't do the division because to use the division rule, it has to be root 4 over root 11, and it's not. So it looks like it's simplified. Now, the issue here is that you don't want to have a surd as a denominator. One of the reasons for that is when you get to more complicated calculations, it's easier to simplify if the surds are on top, for example. So we're going to do something called rationalizing the denominator. The denominator, the bottom number of that fraction, is a surd. Surds are irrational. Root 11 is a number with an unlimited number of decimal places for a pattern. It's 3.31662479, and it continues on. So we want a rational number as the denominator. So we want a whole number, basically. I'm going to write the number a little bit larger to get a bit of working out space around it. And what we're going to do here is we can multiply the top and the bottom of a fraction by whatever we want, and we'll get an equivalent fraction. So we'll do a little example down at the bottom. Let's say we've got a half. We can multiply the bottom by 4 and the top by 4, and that is going to give us 4/8. 4/8 is a half, and 1/2 is a half. So doing the same thing to top and bottom of a fraction, you get the same fraction. So we can do that with surds as well. And what are we going to multiply it by? Well, we need to think of a number we can multiply √11 by, so it's no longer a surd. And there's a really nice way we can do that. All you do is multiply it by itself to guarantee that you have a square number in your answer, and you can remove the surd symbol. So multiplying the bottom by √11, we are multiplying the top by √11 to make sure it's equivalent. So 4 times √11 will give us 4 lots of √11. We can't multiply them together, so we just leave it like that. And on the bottom, we're going to have √11 multiplied by √11, which is the same as 11 times 11 rooted, which is the square root of 121. And 121, we know it's a square number. We know that because we multiply 11 by itself. Of course, it's 11 squared, so the square root of it is going to be 11. So in our next set of simplification, we can take the 4 √11 and we put it over the root of 121, which is 11. And that's actually now our final answer. Now, looking at that and the original expression, it does actually look more complicated. We have an extra number in there. It looks like a larger, kind of weightier expression, but it represents the exact same thing. And the important thing here is that the denominator is rational, which will then, again, make it easier in certain more complex areas of mathematics. So let's try the method again. So again, let's write the number out a little bit larger, plenty of space for working out. We have 10 take away 7 lots of √5, all divided by √5. Now we can't divide both terms by √5 because only one of them has a √5 in it. So we're going to use our rationalizing the denominator method. We're going to multiply the denominator by itself. So we're going to multiply the denominator by √5, and we're going to multiply all of the top by √5. So what does this give us? So let's go through one term at a time. So 10 times √5 is 10 lots of √5. We can't do that multiplication, leave it like that. Then we have 7 √5 times √5. So again, think about multiplying the whole numbers. We only have one whole number, it's a 7. And then you're multiplying the roots. And √5 times √5 is √25. And we know that √25 is 5. It's a square number. So that leaves us 7 times 5. For the denominator, √5 times √5 gives us √25, which again we know is just 5. One more thing to do here, 7 times 5 is 35, so let's write that in. So we have rationalized the denominator. We've multiplied all 3 terms of that expression by √5, and this is the outcome. So you can see the clever little thing here is when you multiply a root by itself, the root symbol disappears. Now, there is actually one extra thing we can do here, and it's because we're dividing the top 2 terms by 5, and both of those numbers actually are in the 5 times table, so we can cancel out. So we can divide the 10 by 5, which gives us 2, and the 35 by 5, which gives us 7. So writing that out neatly, that will give us 2 lots of √5, take away 7, and we have no more denominator because we cancelled out. And no denominator, effectively the denominator is 1, so it is a rational denominator, so we're fine. We're rationalizing the denominator by getting rid of the denominator completely. That's perfectly acceptable. The final answer is 2 lots of root 5, take away 7. So now the final question is going to bring everything we've learned together. So again, let's write it a little bit larger, some working out space. So we have 9 plus the root of 5, all divided by 5 take away the root of 5. So your initial thing here might be, you might be thinking, right, okay, I can see root 5 in the denominator. Let's multiply everything by root 5. So let's try that. So we're going to multiply the numerator by root 5 and the denominator by root 5. So let's start off with the denominator. So we're going to have 5 times root 5 is 5 root 5, and then root 5 times root 5 is 5. Then for the numerator, we would have 9 times root 5 is 9 root 5, and then root 5 times root 5 is 5. So we've multiplied everything through by root 5. Now look at what we've got here. We still have root 5 on the denominator. So this method has not actually rationalized the denominator. All we've done is made the expression more complicated. So what do we do? So again, let's write out what we're working with here. We have our 9 plus root 5 over 5 minus root 5. Now, what we're going to do here is exploit a little quirk of quadratic equations. And what we're going to do is we're going to multiply it. We're going to multiply the denominator by itself. So we're going to multiply by 5 with the root 5. But the key thing we're going to do here is the sign is going to be the opposite. So if it's a negative sign, we're going to be multiplying it by a positive sign. And what that does is that the middle two terms are going to cancel out and give 0. And it'll be the middle two terms that have the root symbol on. Now we do that to the denominator, we also need to do exactly the same thing to the numerator. And it's not going to be 9 take away root 5, it's going to be exactly the same thing, 5 plus root 5. So what we have here now is 2 sets of quadratic equations. So we're going to solve these one at a time. So let's do the numerator first. So we have 9 plus root 5 multiplied by 5 plus root 5. So multiplying everything together, we're going to have 9 times 5 is 45. 9 times root 5 is 9 root 5. Root 5 times 5 is 5 root 5. And root 5 times root 5 is 5. And notice the middle two terms are the terms with the roots on them, and the terms simplify. So now let's add together the whole numbers. 45 plus 5 is 50. And let's add together the root 5 terms. 9 plus 5 is 14, so it's 14 lots of root 5. So that is going to be the numerator of our new fraction. 50 plus 14 root 5. Now let's have a look at the denominator. So we're going to have 5 take away root 5 times 5 plus root 5. So multiplying it all together, we're going to have 5 times 5 is 25. And 5 times root 5 is 5 lots of root 5. Moving on to the second bracket. So we have negative 5 times 5 is negative 5 root 5. And that's really important. The negative symbol belongs with the term after it. It's part of the root 5. And then we have a negative 5 times root 5, which will get us negative 5. And then we simplify. So firstly, look at the whole numbers. We have a 25 and a negative 5. Again, the negative symbol belonging with the term after it. 25 take away 5 is 20. Then look at the roots. We have 5 lots of root 5. Take away 5 lots of root 5. You're taking it away from itself. It's going to give 0. we're going to have 0 lots of root 5. And if we have 0 lots of something, then there's no point writing it down, is there? There's nothing there. We have none of them. So going back to our fraction, the denominator is going to be 20 plus 0 lots of root 5, which I'm not going to write down. And so now when we look at this, we can see that we don't have any roots on the denominator. We have rationalized the denominator. So the trick is, if you have multiple terms on the denominator, you want to multiply it by itself in such a way where you flip the sign in between the two terms like we've just done, and that will get rid of the roots. Final thing to do here is that we can simplify this. And one of the ways we can simplify is I can see that all 3 terms have even numbers. So 20 is even, 50 is even, and 14 is even. So we can divide them all by 2. So 20 divided by 2 is 10. 50 divided by 2 is 25. And 14 divided by 2 is 7. Remember, you can do the same thing for the top and bottom of a fraction, and it'll be an equivalent fraction. So dividing the bottom by 2 and dividing the top by 2, that's acceptable. We can do that. That leaves us with 25 plus 7 lots of root 5 all over 10. And you have a quick look to see if you can simplify that again. But given that one of the terms is 7, which is a prime number, unless we can divide everything by 7, we're not going to be able to simplify. And so 25 plus 7 root 5 all over 10 is the final answer. It has a rationalized denominator.